was introduced with amazing talk. When we remember the first day, it was said that key management is some of the boring stuff. So I'm going to talk about the boring stuff and not the new PQC and quantum computer exciting stuff. Nonetheless, I think key management is important. So my talk is about the robust approach to key storage. We will cover, okay, I've been introduced before. So basically, we're covering today's landscape. And what is today's IT landscape? We all are in CI/CD, so continuous, fast deployment of new releases. Workload typically is containerized nowadays, which means it can go as far as to microservices, where one instance is here only for serving one customer, IT-wise. And we have API and service orientation on how infrastructures are built together. So that is where we live, and an important trend is hybrid operation, on-prem and on-cloud workload. Now, somehow we have to make these all secure. So we use cryptography. What are the drivers? Well, the drivers in many cases are compliance. There are laws out there like GDPR, which are required that you keep your customer data safe. Then there is regulated industry, healthcare, finance, payment industries, which all require encryption, or if they're not technically required, there is no other option to fulfill the requirements. And then there's things like qualified signatures laws, meaning you can sign digitally equivalent to your handwritten signature. Then another topic that has been mentioned many times in all the presentations, privacy, confidentiality of your data, IP protection. You probably don't want your secret recipes to go out to somebody else. You want privacy on your network, so TLS, since we are an OpenSSL conference, TLS is an important topic. And also things like blockchain. Then cryptography can also help in cyber protection. If your data has been stolen, but it was encrypted and you are the only one that holds the key, you're much better off than if it's vice versa. To reduce those things, we have things like data at rest encryption, database encryptions, cloud data, double key encryption for those who use Microsoft. In the cloud, that can be a very effective tool. Encryption, not really encryption, signatures are also used for access control. So typically things like JWT tokens, OAuths, and verifiable authenticity of emails. Everybody should use S-MIME to sign their message. It would also help your spam scanner to make the big difference. So these are the key driver of encryptions, and if you have encryptions, of course, you have a lot of keys. Let's have a look at a typical, or maybe exemplary infrastructure. We see clients, which typically today are web clients, which connect to ingress controllers, which then go to the workload containers, which are probably run in a Kubernetes, which again use other servers from other places, and some of those containers, of course, use databases to make some lookups. And, we have a lot of protocols, and in many cases it's TLS between them. And if you have protocols, well, for authentication, you need keys. So keys authenticate whom you're talking to, and of course, you have additional ephemeral keys for the session. And if we talk about database encryptions, even more keys are used to encrypt your columns, or your whole database. So those keys have to be managed. And if you look how many they are and think about your infrastructures, that could be a very difficult task. Let's explore a little bit more what we are really doing with those digital keys. We have the encryption side and we have the digital signature side. On the digital signature side, typical applications, of course, PKIs, which is to issue certificates, which you then use for authenticity, identity of users and machines, and as I said, signatures, which are used in the real world to represent you that you have signed off. On the encryption side, we have encryption on many layers. We have things like drive encryption statically on your hard drive. If you go to the networking side, on the same layer, you have layer 2 encryptions like MACsec as a prominent protocol. On the next layer, we have SSL, TLS everywhere. So basically, any web server now runs in a at least privacy encrypted mode using something like Let's Encrypt. But if you want to make sure that you really talk to your bank, you probably have a certificate from a trusted third party on the other side. The equivalent in the static side is file encryption, which keep your files safe also from administrative threats. On the next level, things higher valued applications like databases, where you have TDE, that's transparent data encryption, which basically covers the whole database. Can also be column by column or table by table, or in the extreme case, it moves out to the end in a system like Microsoft's Always Encrypt, where the data is only decrypted at the place where you really use it. And if we go even further, there were some mentioning in previous talks as well. We have record encryption, so each and every record is individually encrypted, and at the very highest level, the data is even processed in encrypted form. That is possible for a few cases. It's more a research topic still, but of course that is the optimal case. If the data never leaves the encrypted space, it is also never vulnerable. And for all these things, you have keys, and those keys need to be managed. So what about key management? Let's have a reality check. How is key management done? Well, the simple key management is the keys end up in a file. And that simple key management, unfortunately, is still a very prominent one being used everywhere. But it has, of course, some issues. Key security level low. Well, every administrator, everybody with access in that group can access the key, can steal it, copy it, keep it, and use it when he wants to. So obviously that is not the best way to do it. If you go to a higher level of security, especially when it comes to compliance, so especially when there is mandated compliance, the keys are probably going to go into hardware security module. And also having those keys in files probably is not that scalable. So if you go to a cloud system like AWS or Google Cloud, you need a distributed key management system over all the regions you are in. So what is key management really doing? Well, it's quite simple. You list all the keys you have. You want to know where they're used. You want to create keys. You want to delete keys. An important thing is, of course, you want to roll over keys. What is key rollovering? It's quite simple. Since keys may be vulnerable after a certain amount of usage, you want to go to the next iteration of it. And we talk about rollover instead of recreating keys in the case that the same application with the same requirements is being run with the next generation. Key management is also about associating keys with applications. You want to have some rules on those keys, who is managing them, who is be able to use them, access policies, and very important, also for forensics, you log the usage of those keys. This is key management. So how is it typically done? And yes, I forgot to mention that. Of course, you need to do that across the whole IT infrastructure you have. It's not an island thing where you can do it in one place. You have to do it across the IT infrastructure. I've been talking to also some people which are here on the conference. A typical IT infrastructure nowadays in a corporation has many thousands of such keys, and many companies even struggle finding where all those keys are. So that gives an opportunity for a KMS. How does a KMS typically work? Well, you have a database with all the keys in there. You have a piece of software on top of it which should be managing the keys. It typically starts with that a key encryption key unseals the whole blob of keys which are in the database, so the KMS can then use this. And then when an application requires a key, it requests that key from the key management service. The key management service authenticates the applications, checks the rules, and then hands out the key. So far, so good, but there are still some challenges here. First of all, there is no one single protocol to do that. There are many protocols which are used in the industry. We have things like KMIP, we have PKCS11, we have Java JC, Microsoft's Crypto API Next Generation, we have REST APIs, we have from multiple vendors in different cases. If you work like this, you have still key exposure. The key is going out. After it has left the KMS, you don't know what it has happened. In that case, you will have no key audit logging. You don't know when and how it is used. An unsealed key store has key exposure. Once it is unsealed, you can use any key from anybody, including the database administrator that have access. And if you look at this, we have a redundancy problem in a real IT infrastructure. A single instance is never good enough. You need everything at least doubled in redundancy. So how can we improve? Well, okay, we make the redundant KMS. So we now double the key stores, we double the KMS, we give the applications the ability to fetch the keys from either side. So if one of the KMS is going down, then the other can take over. You might think that's not that important. It is absolutely crucially important. If you look at AWS, which, for example, which is securing every blob of information with keys, and if this goes down, none of your user is doing anything after 1-2 minutes. So it has happened in the industry with large corporations that exactly they ran into this case, and I'm sure you know that the management was not exactly happy. So when you do those replications, of course, now the policies have to be replicated across the instances. The keys have to be replicated across those instances. And this also creates quite a bit of challenges. And it's probably not a good idea to have this master and key encryption key on the file system. These keys probably should go into a secure storage like an HSM. But still, now that we have this redundant system, we still have challenges. Well, we have not solved the multi-application protocol access. The replication using databases may not be the right replication for what we have want to achieve. The keys, while we have the key encryption key now securely stored, those keys are still vulnerable after unsealing. Everybody with access to the database or to database tables, especially the database administrator can technically exfiltrate all the keys and then do whatever he wants with those. And well, if keys are generated in software, and you know, for those which are in crypto, keys typically in generation need a lot of entropy. They need good random quality. Well, if you do that in software, this is typically doubtful. So that problem still exists. And a system like this with replication of keys, well, if you have stateful keys, because the most secure keys are hash-based cryptographic keys, they might be stateful, you have an issue. So, and many people in the industry use different tools. A KMS would, if it's used like this, have to do all these cool tools themselves. So it would have to integrate a PK, it would have to integrate secrets management, all those nice tools would have to go into here and you have a unified interface. A rather elaborate task for such a piece of software. So maybe we have to look at it slightly differently. We just turn things upside down. At the core of what we have seen is basically a key store. So we want to keep keys in a secure key store. So if we have a key store with unified access control, with policy control, then managing the key becomes much simpler, because now any protocol which can access the key store, and that's very typically like things like PKCS11, can have then the same rules. And the KMS then becomes into a system which just manages all those keys in this infrastructure. So how would a system like that look like? It is maybe slightly overwhelming as a slide, so I guide you through it. We have at the bottom, we have the secure key stores. Of course, as an HSM vendor, we believe that the only secure key store are HSMs. And HSMs, if done properly, they can automatically replicate the keys also between sites, between different HSMs. So you have redundancy, you have scalability, also in terms of performance. On top, you see different protocols which talk to the HSM, REST, KMIP, XKS, for those, that's the AWS external key store. So you keep the keys which are used in AWS to encrypt your load on your prem or in your sovereignty. If you look at this, then even other things like PKI can use the same key store. Also, Vault or OpenBAO secrets management can use the same key store. Databases can use these key stores with different access protocols. Then we have mentioned the cloud key storage. IAM systems for authentication of users, same key store. And via a key exporting protocol, many applications with high scalability where the decryption has to be done in the application for scalability reasons can use the same key store. So you still have the benefit of good quality keys, a known place where they're stored. So you don't have to go and look around in your file system where all your keys are. You know where they are. And with an overlay of a key management system, you can now visualize and do all the key management tasks. And this across all protocols, across all tools, from different vendors. You can do the automation on the same thing. So you can make scripts which do your key rollovers according to your policies. And you can visualize where you're going to run into troubles. And last but not least, very importantly, you know how the keys and when the keys have been used, so you have a perfect audit logging. So this is something we are working on. as a concept and also as a product. It's not shipping, but it's the vision we are following. And we do that for the reasons I've just mentioned. So I want to skip that slide first. So what are the preconditions that this can be achieved? Well, of course, now the key store has to enforce all the roles. So we have things like a key management role enforced by the HSM, by the key store, a key user role. And very importantly, each key has to have the ability to have its own policies, so that those policies can be enforced over all protocols. So a key could be generated in one protocol and then used by another protocol. And still, since the key store enforces the access policies, it is done in this way you have specified it. So let's go back. So what have we achieved? We have achieved key management, on my view, on the next level. We have a fully redundant, fully scalable to millions of operations per second, which can be extremely useful for things like AWS. We have keys can be shared across platforms. You can use them hybrid, you can use them on-prem, you can use them there's probably no other option than those two. You have a unified view and access control, very important. So a key is a key, and you don't care which protocol is going to use it. Key has a policy, no matter which protocol you're using, and even if you switch protocols, it's still the same key. These things seamlessly integrate with PKIs. You need a PKI if you do certificates, believe me. PKI, managing certificates just with an OpenSSL and a few scripts is not scalable. You can combine it with secrets management. That becomes more and more important in the organization. You can easily extend it with third-party tools, so not everything has to be done and reinvented into a KMS. The thing can just be extended with tools done by other smart people. And important compliance, keys can be created, stored in a FIPS and CC evaluated certified key store. So in many cases, your next audit becomes dramatically easier. And that is basically the message I wanted to give. As we are HSM manufacturing, a few pictures of what an HSM are. I think many in here have seen it in other talks. People have no idea what it looks like. It's typically a 19-inch device, network attached, which you deploy in your racks somewhere. Never alone. It's always running at least in double. And in most cases, it runs in multiple data centers. You want to try something like this out, we have a self-service portal. We also run HSM as a service across the globe with data centers from US West, US East, UK, no, not UK, Germany, exactly, Switzerland, Singapore, and maybe some other jurisdictions where I'm not sure. We have a self-service portal. You will get access to what I have been talking about automatically, of course, as a cloud service. So with that concludes my talk. Thank you very much. And I'm open for questions.
Hello, my name is Holger. Where do I store the access tokens for the keys? So the key is stored in a secure way, I understand it, but how can I authenticate myself as an application or whatever, so that the KMS system is knowing that I am a trusted entity to get access to that key and use it?
Absolutely. You still have, of course, some authentication tokens of whatever sort. And yes, those are typically still with the applications. That's because that's where they have to be. And of course, those are still vulnerable in that sense that somebody could take those and then get access to the key store. But even if that happens, you still have a more defense than having the key out there, because you are not going to lose the key. Somebody might access it and use it, and then it will show up in your audit log and you will see strange behavior, but the key is still with you. If the key would have been gone, you are lost. You have no clue what's going to happen in the future.
Great. Any other question? You know, it's morning, so I hope it's okay. Thank you so much, Marcel.
Thank you.
Please, one more applause. Thank you.